So can you see my screen now? Great. So in the repository, we have under week 3, we have all of the material. So yeah, it's about pandas and exploratory data analysis. What we want to cover is basically different operations that you typically do under EDA. So we want to see how we can visualize the statistical features of a data set with pandas and matplotlib. How can we filter a data set, like filter some rows or filter columns? How can we do aggregation with pandas? So yes. Okay. I guess please mute your microphone. So how can you do aggregation with pandas? So basically, for example, we have a set of data set and you want to know what is the average of some feature per each month or per each week. So you need to aggregate the data points. How can you join 2 data sets? So sometimes your information are spread across 2 or more data sets or data frame in pandas. So you need to join them. And also, if you have time, I will show you some more advanced visualizations that you can do with pandas and matplotlib and also other visualization libraries. But if we couldn't make it, I'm sure you can also review it at home. It's a short notebook. So we start with the notebook called EDA and Data Visualization, which is this one. And this notebook essentially presents 2 examples of EDA on real-world datasets. So one of the datasets is about inspections of restaurants in New York City, and the other one are the data collected about vehicle collisions, which is from New York City Police Department. So gonna start with this one. You can open the notebook directly from GitHub and just open it in Collaboratory. Okay, part of the stuff in this notebook could be repetitive. I mean, we have reviewed it last week, but we can still just review them and maybe pass quickly. So for the setup of this week, because we are also gonna do some visualizations with matplotlib library, so we need to import it. And remember from the first week lab that whenever you wanna just have some graphs with matplotlib and just have them in the notebook, so have them rendered in the notebook. So you have to basically use this magic command, which is a %sign matplotlib inline. Otherwise, you wouldn't be able to see your graphs inside the notebook. And we mainly need pandas and NumPy and also matplotlib and Seaborn, which is also another visualization library, which basically works on top of matplotlib. It essentially gives you like more beautiful and more beautiful plots. Okay, this is just the details. We're gonna just set the style of all of our plots beforehand. You can just maybe look them up online to see what are the different styles that you want to use. Here we want to have white grids in our plots, so we just use this style from Seaborn. Okay, so we will start with a simple example. So it's possible to create a data frame from scratch, and you can basically do it with different types of with different types of variables. So you can create a data frame from a dictionary, or you can create a data frame from a list of lists. In this example, we are creating a data frame from a list of dictionaries. So each dictionary has 2 keys, first name and last name. And when we just apply pd.data frame on this list of dictionary, we just get a data frame. And you can see that, for example, in the third element of our list, the dictionary didn't have actually the key first name. So that's why when you just create a data frame, you will have a null value here. But that's essentially how you can create a data frame from a dictionary. You can also do that from a list as well. Yeah, except that if you do it from a list, because you couldn't have these key value pairs in a list, then you couldn't actually have the column names if you have only a list of lists. So probably just dictionary is a more proper way to convert to a pandas data frame. Anyhow, after you have just created your data frame, you can easily change the column names and row names, so it's not really a big deal. So that was just a simple example. So let's start by loading the data sets of inspection of restaurants. So we load it, it's a CSV file, and we load it directly from the URL that contains the data set. So this is again the details, so the encoding and so on. So by running this cell, you will get the data set and load it in a pandas data frame. It may take some time. Yeah, and also if you don't want to do it directly from here, an alternative is to just download it from this URL and then just load it from your local computer. Yeah, that's also a possibility. Anyhow, you can see it's this dataset has lots of features. So, for example, you have the neighborhood where the restaurant is, the address of the restaurant, the zip code, which type of cuisine is that, and basically what was the violation code. Well, when the restaurant was inspected, there were some violations. So what was the violation code? And the scores, the geographical coordinates of the restaurant and so on. Okay. So typically you have the real world data sets are like this. So you have different features and you want to just basically run an analysis on maybe some of them and just get some statistics to get an idea of the data set. So the first statistic that you can use is basically generally this describe method, which you can just run on a pandas data frame. Probably by running it on the whole data frame, we won't get a very interesting result because we have lots of columns in this data frame, and most of them are just string columns. So by default, when you load such a data set with pandas, you get like all of the data types are just objects. So you cannot really get really insightful statistics from them. So probably it's better first to just clean the data set, meaning that just correcting the data types, or if there's a categorical feature, converting it to categorical, and then probably run describe on the numerical columns and non-numerical columns separately. So I think we will do it later, in the next steps. So as I said, if you check the data type, yeah, all of them are object. So for some of them, we need to change it because we know that they are not string, they are other data types. Like, I don't know, for example, this, this score is probably a numerical column, so we need to convert them. As you have seen in last session, we can do it by using a two numeric method from pandas. And for example, for the score, you can just applied to numeric, and then it will be basically a numerical column here. The data type was converted to float 64. Okay. And then now, if you just run describe only on this score column, you will get like a more appropriate result. So you get the cons, you get the mean, standard deviation, minimum, and like different the values on different quartiles, and the maximum. So after just correcting the data type of the column and running the describe, you will get a proper descriptive statistics on the column. Another insightful, also another thing which could be insightful for numerical columns is histogram, obviously. So histogram basically gives you an idea of the distribution of the values in a feature. So if you just, so in pandas, what you can do is basically you can apply this hist method, which directly plots the histogram for you. Another way to do that is basically using the plot method, and then in the attributes, just setting the kind of the plot to histogram. And this is really comfortable because you don't need to basically use the matplotlib plot and just plot the one of the columns of the data frame. So pandas has already this plot and hist method, and in the backend it uses matplotlib, so it just makes your life easier. So by running it, you just get the histogram of the score of the score values in this dataset. Okay. So when you use histogram, by default, the histogram has 10 bars, but depending on the distribution of the values in your dataset, maybe you should change the number of bars. And by just increasing the number of bars of the histogram, you are basically increasing the resolution of the histogram. So here, for example, if you just plot the same histogram with 50 beans, you will see more finer, you can see finer details of the distribution of the score values. No, you can actually see that the distribution is not like exponentially decreasing. It's rather, something like, yeah, it has some peak and it increases to the peak and then decreases again. So I'm not sure which distribution is this, but I think it should be yeah, for example, some skewed Gaussian. So I mean, by increasing the number of beans, you may have finer details of the histogram, but the time that it takes to compute the histogram also increases. So for example, you can also try with 100, and you can see more finer details of the distribution. Okay, this is okay, and also this is just yeah, this is also the same histogram, but here we just limited the x-axis to only 50. And the reason is that, so histogram just shows all of the values that you have in your dataset and how frequent they are. And here you can see that most of the values are in this range, the range between 0 and 50. But you have also some values until 100, but then there is not much really after that. But why still we have like this x-axis until 150 or maybe 200? The reason is that probably there is like, even if there is like a single value with 150 or more, then because it has like a frequency more than 0, then your histogram basically considers that as the limit of your axis. So, and sometimes because you may have this kind of outliers in your data set, you should be careful that maybe you have to remove them before plotting the histogram to get maybe nicer shapes for your histogram. And also it gives you more insight about the distribution, about the true distribution of the values in your data set. An alternative histogram is also to use the kernel density functions. And what kernel density does is that it estimates a continuous function instead of these discrete histogram bars. And the way you can access it is basically through the plot method and using the KDE for the kind attribute. Here you can see that we will see the same figure as above, but with like a curve which has been, you know, approximated using the above figure. Okay. This is usually, I mean, this is usually useful if you want to basically know what is the distribution of your dataset. So your dataset is discrete, but your assumption is that there is like an underlying continuous distribution from which your samples have been drawn. So this is useful for that and other statistical analysis. Another thing which we also did, I think, review last week, so I will just pass quickly, was converting the dates. So we said that, again, the date columns could also have the object data type. Here, probably this happened because you have both the null values and also probably pandas did not recognize this format as a date. So you have to basically convert it to a date format. So for that, we show last week that we use the toDateTime function. And we show that also we need to specify the format of the date in our date column. So the small m indicates the month, the small d indicates the day of the month, and y indicates basically the year with 4 digits. And also note that this %m and %d are basically the decimal number of the month and day, but they are zero padded, meaning that if the day of the month is less than 10, so you would have 0.3 instead of just 3, which is basically the format that we have here. So all we have to do is just use this toDateTime method and apply it on the grade dates, which is like one of the date columns in our data frame, and specify the format as like this. So you see it's fairly easy. So we say that, okay, we have the month, and then we have this slash, then we have day, and then a slash and year. And this way, pandas understand the formats and can successfully convert the data type of the column to date. And if you look at the data types again, you can see that now the 3 columns, grade date, record date, and inspection date, have the correct format. Now we can even run descriptive statistics on the date columns. And we can see, for example, what is like the oldest date and the recent date in our data frame, and how many and how many unique values are there, and so on. Okay. So there is also an exercise here. Okay. The exercise wants you to plot a histogram for the inspection date, grade date, and record date. And yeah, So if you just do it on the row column, okay, this is an example for which this histogram plot does not really give you an insightful result. And again, the reason is that you have probably some outliers in your data frame. So definitely the inspections are just for recent years. So you really wouldn't expect to have an inspection from 1900. So this gives you a hint that there is probably a problem in one of the data samples and there is like some outlier. So that's why you cannot see anything really insightful from your data frame, okay? But even just increasing the bins here wouldn't help you because I mean, even if I just increase the bins to, I don't know, 50, it wouldn't help you much because still the outlier is too far from the main data samples that it doesn't help to increase the bins. So instead, what we have to do is that we have to basically restrict the range of the values in your x-axis. Okay. Okay. This is okay. This shows that for the grade date, the histogram is like more reasonable. So the reason is probably because that there is no. I mean, there are no data outliers which are far from the main samples of the data. But anyhow, for the inspection date, what we can do is basically restrict the range on the x-axis, and we can just simply do it by by using the range attribute and setting it to the range that we want to have. So here we want the range to be between 2014 and 2018, and you can also set the bins. Okay, wait a second. Okay. Yeah, there is a problem here because I guess, yeah, this is not really okay, because that range is not really understandable like this. So I have to give the range as proper datetime format. So here I should just yeah, should do it like this probably. Yeah, sorry, I did not correct it, I guess. Okay. Okay, also. Okay, this is also not right. Okay, like this, it should work, I guess. Yeah. So, okay, because this column had this datetime format, so we also had to give the range as datetime format as well. So this should have been done like this. Anyhow, by just restricting the range, now we are getting a histogram, which makes much more sense and is just much more insightful. And we have to do the same also for the grade date. I would not do that for now. Probably, okay, I can just copy it here so to have the thing correct. Yeah. Again, I hope this is clear here for now. So previously, I was just giving the range as strings of the date, but that was not correct. And it was not acceptable because this grade date is now a datetime format, has now the datetime format. So we should have also given the range in datetime format as well. So I hope it's clear for everybody. If not, please interrupt me. Again, we also mentioned last week that sometimes you have categorical features, which are the features which take values only from a countable and finite set. And for those features, you may want to basically convert them in pandas to categorical data type. Here in this data set, we have a couple of categorical features like the violation code or the critical flag, or for example, the action that the regulatory department want to take on the restaurant. So we want to just convert all of them to categorical features, and we can do it by using the categorical method from pandas. So we use pd.categorical, and here we just say which column we want to convert to categorical data type. And also there is also another attribute which is called ordered. Okay. So if you just look at the documentation, it says that, okay. Okay, by default it's false, and basically by setting it true, you are specifying that your categories are basically some ordered categories. So for example, if you have a categorical features which take values from like 1, 2, 3, 4, or A, B, C, D, E, F. So these are kind of ordered categories. So you may, so you can just set ordered equal to true, so that we specify that this is like an ordered category. And this is useful because if you have an ordered categorical, then it respects the order of its categories, and yeah. Okay, so by running this cell, we just convert all of them to categorical data type. And now we can see that all of them has been converted to categorical data type. So I guess there's a question. Yes, you should import the date time. Yeah. Okay. The other, so in the next section, what we want to show is how we can analyze the contents of columns. And so we have already seen describe. Another thing which could be useful for you to use is the value counts method. So what value counts gives you is basically how frequent are each values in a column. So for example, the column DBA is a numerical column, and I'm sorry, is a string column, and they are basically I guess, yeah, probably it shows like the chain restaurant or the chain that the restaurant belongs to, probably. So you want to see how frequent are each of these values in your data set. And then you can just easily do it by value counts. And by doing that, you will see that, okay, for example, the subway has been repeated like 2,900 times in the DBA column. So it kind of gives you some sort of a statistics for this column. So you can do it also for the cuisine description. And you can see that, for example, the American cuisine is the most frequent cuisine type among the restaurants that we have on our data set. And so if you have the value counts, you can essentially plot a bar plot, you know, have a bar plot from the value counts. And this gives you a plot which is really similar to a histogram. But it's kind of like neater from the histogram, because here you have some sort of discrete values in the cuisine description column. So, and probably you are just interested in like the first 5 cuisine description. So maybe it's like it's like linear to just first do value counts and then try to do a bar plot, which just shows you, like discretely shows you how frequent each cuisine type is. Yeah. So just I want you to just understand the difference between the bar plot and the histogram. So essentially, histogram is more useful when you have a numerical column, and which are just, you know, continuous values, like what we had in the score columns. But bar plot is more for the columns which have really discrete values or categorical values, and you want to basically visualize how frequent each category is. So for that kinds of statistics, probably bar plot is more appropriate. Okay, this is again the same. Okay, this is okay, and here we show that we can actually change the values in a column of our data frame. And in this example, we see that, for example, for our cuisine description, we have a category called Latin, which has Cuban, Dominican, etc. in the parentheses, and say, okay, if you want to just change this value and just make it shorter, you can do it by using the replace method from pandas. And then you apply this replace method on the cuisine description column, and you specify that you want to replace this value with just Latin American values. And again, you can do this operation in place, so the changes would be applied to the initial data frame. So there are also other examples of this. And then now if you just plot the bar plot again, you will see that it's nicer because you only have Latin American here as an axis legend. Whereas previously you had this huge and long axis legend, which was not nice. Anyhow, this is just for you to know that you can use this replace method if you want to just change, well, replace some of the values in a column to another. So to change a value in a column. Okay, and I guess this is also the same. So the same bar plot, but no for the violation code. Okay. This is an exercise. This is again the same exercise. You want to just plot the number of inspections that happened across each neighborhood, and because again, this is again some discrete value, so you first need to just use this value counts function to just count the frequency of inspections in each neighborhood, and then plot plot a bar plot to get the number of inspection in each. I mean, to get some sort of histogram of the number of inspection in each neighbor. So the only new point here is basically that when you do bar plot, if you just use the kind bar, it gives you these vertical bar plots, but you can also use bar edge. which basically gives you horizontal bar plot. So it's the same plot, it's just the orientation just changes. So here you have these vertical bars, but here you have horizontal bars. So this is, I think, again, you know already. So you can select a subset of columns like this, or you can just make a list of columns and select a subset of them. For the rows, okay, this is okay. It's better to review it. For the rows, there are different ways to select them. It depends what you want to do. So here, usually the way you want to select the rows is basically by filtering. So for example, you want to just have all of the data samples for which the violation code was basically 04L. And then the way you do that is basically you just create some sort of conditional statement which gives you Boolean values. So it basically gives you a series of Boolean values, and where this condition is false, it just it has false, and then whenever this condition is true, you have true. And then basically you can apply this condition in the form of these true false values to your data frame, and then you can filter the rows for which this violation code was 04L. Okay, so all we did was basically we created the condition mice, because this violation code 04L apparently shows the mice, that there were some mice in the restaurant. So we created this condition, and then we just said, okay, we just want the restaurants and the columns for which this mice condition was correct. I mean, note that you could have also done it like directly. So, I mean, like this. So you could have written like restaurants for, and the rows for which the column violation code was 04L. So, and you will get the same result. Okay. Okay, this is again the same, but you can have even more complex conditions in form of AND statement or OR statements. And again, you can just define the condition. For example, here we want the violation code to be 04L and also the neighborhood to be Brooklyn. And by just applying this condition to the data frame, you just get all of the rows for which you have the 04L violation code and the neighborhood is Brooklyn. Once again, you can apply it directly here instead of just defining a condition separately and then apply it on the data frame. So you can just do it like this. I mean, it's essentially the same. Just remember that you have to enclose each condition in parentheses, and you're good to go. And it just gives you the same result. Okay, the next topic which I want to show you is basically pivot tables. So pivot tables are really useful, and you may commonly need to use them in your exploratory analysis. And basically what they does is that they do some sort of aggregation on your data set. And later today, we will come back to aggregation when I introduce to you the group by method in pandas. But just for the sake of example here, for example, let's say you want to count the number of restaurants that are inspected every day, okay? So basically, we want to know how many inspections were in each single day, okay? So, and then you can use this pivot table method from pandas. And okay, the data attribute, basically with the data attribute, we want to just specify on which data frame we want to apply the pivot table. So the index is basically the column on which you want to aggregate the data. So we want to aggregate the data on the inspection date. And the values that we want to aggregate are these, Camis value, which is like the, I don't know what does it mean, but yeah, this is like the identifier of the inspection. So it's a unique value. And then we say that the aggregate function is count. So what does it mean is that for each inspection date, just count the unique these Camis values, okay? And by doing that, we will get a result like this. So it shows us that, for example, on the 13th of September of 2014, there were like 4 inspections in total. Okay, so these are really useful because it happens a lot that you need data aggregation in your analysis. So how many inspections were in a day, how many inspections were in each month, you know, how many mice violations were in Brooklyn, or which neighborhood has the most number of violations, and so on. So, you know, all of these questions can be answered by data aggregation. So data aggregation is actually very important. You know, again, like it's not always counting the number of values for a specific, feature. It's sometimes a mathematical calculation. So, for example, the average number of inspection per year, for example. So all of these questions could be answered by data aggregation. And pivot tables is one of the ways to aggregate the data. Another way to do it, which is like more common, is basically group by, which we will get back to it in a shortly. And after we do the pivot table, you can also plot it. And so here we do a simple plot. So it just gives us like a line plot, which is again not really insightful because we have this outlier rows with 1900 date. So here in this section, we say that, okay, we can delete actually some rows from a table. So in this example, we want to delete the rows that have this 1900 date. So, and the way we can do it is basically by using the drop function. So here, note that when we did pivoting, now the axis of the resulting data frame is basically the inspection date, okay? And when we want to drop some of the rows, we can actually just give the values of the index that we want to drop, which in this case is basically 1st of January of 1900. Again, we have to first convert it to date time. And by dropping it, we will see that we don't have it in our pivot table anymore. So the first date is now 2012, whereas previously it was 1900. So all of them are removed now. And okay, sorry. And if we plot it again, we'll see that the result is actually, it makes more sense. Okay, sorry. So this is the plot of the whole values. You can also plot the same. You can also have the same plot, but only for the last 50 data samples, and you will get like more visible plot. And okay. Of course, you can also do bar plots here, but probably there are like lots of different categories here because we have a single category for each day. But probably a good idea would be to just plot the same for like a more coarser granularity, like a week or a month or a year, and see how many inspections were in each, for example, week or year. And And how can we actually change this date granularity? We can actually use this resample command. And what this resample does is basically changes the frequency from 1 day to 7 days or whatever number of days that you want. So let's say, for example, we want, yes. Okay, I thought there was a question. Okay, for example, if you want to compute the average for per week of the average inspections per week, you can first resample the date for 1 week and then just compute the mean, and you will get the result like this. So you have a lot of you'll see that you have a lot of null values in here because probably the data is missing for some of the dates. So that's probably what's happening. Yeah, even if you see the head, yeah, because here you have like yeah, you have every week you have the every week in the year, but for sure in our data set we don't have inspections for every week. So for the weeks in which there were no inspections, we just get null values. But anyway, the point is that right, like this, you can just have like coarser granularity of data. In here, for example, you can have the same plot for the average per week or the sum per month. So there's lots of flexibility and you can do different things. Okay. Okay, I will skip this. You can read it later. So pivot tables with 2 or more variables. And I think you can also do the exercise. So there is also another section with a new data set, which is NYPD vehicle collisions. I mean, it's essentially the same exercise. So just load the data set and try to plot different graphs and do some pivot tables and so on. So you have the exercise here with the explanations on the top, and you have also the code here. So you can just run the code and see the result, and if you want, you can play with it. I guess there is not enough time for me to do it in the online session. Instead of that, but please try to do the rest of the notebook at home. Also, these bonus plots are also really cool. So with that, you can actually visualize the accidents on the map and see which parts of the cities had more accidents and so on. So try to do it and the results would be really cool. Okay, but don't worry if you don't understand this part, because probably this contains some advanced features of the matplotlib, but still, if you can figure it out, would be great. I mean, it will just increase your skills and knowledge in matplotlib, and also gives you idea maybe for your future projects if you want to have similar visualizations. Okay, but for now, there are two other notebooks which are important, and I want to review them as well. And these two notebooks are about two important operations in pandas. The first one is aggregation, and the second one is join. So the aggregations we see actually in the previous notebook. We see two examples of data aggregation, which we did it with pandas, with pivot. But here we will review some more advanced data aggregation. Okay, I don't know why this link didn't work. Okay. Okay. Okay, for this notebook, we will use a data set which is about you know, the transactions that that the customers did. So the customer identifier, the date of the transaction, and how much she or he purchased, and so on. Okay, so we load this dataset. The dataset is available in GitHub in the repository, so you can just load it directly from there, and you can just load it into a data frame. So yeah, this info method, when you just apply it on a data frame, it basically, yeah, as the documentation says, it prints a concise summary of the data frame. So the information is basically the column name, if there are like some null values there, and what is the data type basically. Again, here we have the transaction date, which should be a date column. So, but it's not as we load the data set. So we just convert the date again. And we see that the date has apparently been converted successfully. Well, so we didn't have to specify the format here. So pandas managed to you know, identify the format itself. So if you just do my data trans date and head, you can see that yeah, the date has been successfully converted to datetime format. Okay. So let's start with some simple aggregations. So let's say we want to know the sum of you know, the sum of all of the purchases that each customer did. Okay. So for aggregations in general, we use a method in pandas which is called group by. Okay. Again, if you just look at the documentation, a group by operation involves some combination of splitting the object, applying a function, and combining the results. And this can be used to group large amounts of data and compute operations on these groups. So basically what group by does is basically splits your data into different groups, applies a function on each of these groups, and then combines the result, okay? So in this case, we want to know the sum of the purchases, the sum of the amount of the purchases for each customer. So we split, so we do group by, but what happens actually is that group by first splits your data set for each customer. Then for each customer, we just, you know, apply a function in which here is basically the sum of the purchases. And then after applying the function, we just combine all of the results. So how we do it in the code is basically we say group by, and then we want to group, and the group by is on the customer column, means that we want to aggregate the data for each customer. And after that, we say that, okay, after you just aggregate the data for each customer, we want to sum the values in the purchase amount column, okay? And by running it, you would get the following result. So by default, when you just do group by and do some functions on the grouped, on a grouped column, then in the result, you would get a data frame for which the index is basically the grouped column. So if I just do that, here actually I get a series because you know, I only have one column. So, but the point is that the customer is actually know the index of the series, okay? So, but if you don't want this to happen, you should actually use this as index attribute and set it to false, okay? So by setting as index to false, you will you just by setting it as false, then for your aggregated output, you know, you don't have the aggregated column as the index. Rather, there would be like a new index generated, which is usually numbers from 0, yeah, numbers from 0 and so on. Okay. And so this is like a simple example of aggregation. So here we use this .sum function directly, which is a predefined function. Well, it's like a predefined function from pandas. You could also use, for example, mean, and instead of the sum, you could have the mean value of the purchases of each customer. You can also have max, which gives you the maximum amount of purchases each customer did, or there is also minimum, which gives you the minimum. So you can see that you can do different mathematical operations. Okay, but there is also alternative way to do it, and you can use the aggregate method. So you do the same, but here instead of just .sum, you just do .aggregate, and then in the crochet you specify that you want to do a sum operation. Okay, and then this .rename method is essentially just for renaming after doing the aggregation, you just want to rename the purchase amount column to aggregate purchase. Okay, no, but it just essentially gives you the same result. But here the point is that sometimes you want to do some sort of aggregation, some sort of function, which is not really defined in pandas, like mean, sum, or maximum, or etc. So for that, you can have your, you can define your own function, okay? And then if you want to apply it in a group by operation, you should just use this aggregate method. So you say that, okay, I want to aggregate this column with this function that I have just defined. Oh, okay, there is no index column when we do aggregate. Here they should have been, because we set as index equal to false. But okay, let me check. Yeah, apparently, yes. So when you do aggregation, so and okay, when you are doing aggregation and you have set the as index equal to false, it still does not add a new index, and it uses the grouped column as the index, which is a bit weird. Anyway, but you can, there is also other ways to avoid it. So if you're in such a situation, what you can do is just do reset index, and by doing reset index, you just reset the index of your data frame. So when I do reset index, I just reset the index of my data frame. Now we have a customer column again, and then we have our usual index of the data frame. Yeah, this is just a workaround to solve it, but I really don't know why with aggregation this as index attribute is not working. Yeah. Okay. So a more advanced way, okay, here we show maybe a more complicated example of aggregation. So let's say we want to apply multiple aggregation functions to a variable. So for example, again, the previous example, but this time we want to compute the maximum of the purchase amount and also the sum of the purchase amount for each customer at the same time. So we want to do two aggregations at the same time. Okay. So here it's the place where we should use the aggregate method. Okay. And the way we use it is that we say that, okay, we want to do aggregate, and we want to create a new column, which is called aggregate purchased. And for this column, the aggregation function is sum. And we also want to have another column, which is purchase maximum. And the function of aggregation for this column is max. Okay. And by doing it, you will get this result. So you just did like two aggregations at the same time on one column. Okay, so it's basically you are aggregating, you are aggregating one column, which is the customer column, but you are applying multiple aggregation functions. So this is more correct to say actually. Okay. Okay, this is just, you can also apply this sum on the whole data set as well. So we just want to know the sum of all purchases in the whole data set. You just do my data purchase amount, that sum. So it gives you the whole sum. Okay, and okay, I guess we can just skip this part. Okay. Here again, there is also another complicated example. So, and this is about applying multiple aggregating functions to multiple variables. So, for example, in the previous example, we were grouping the customer column, and we had two aggregating functions on the same column, which was the purchase amount. But what if we want to group by, again, the same column, the customer column, but we want to have like two aggregation function, but on different columns, which is in this example is basically, again, we want to group by on customer, but we want to, for example, find the maximum of the purchase amount and also sum of the quantity. Okay. Or let's say even like maximum and sum on the purchase amount and sum on the quantity. And again, we can use it again with the aggregate method. And we just say that, okay, for the purchase amount column, we want to apply these two aggregation functions. And for quantity, we want to use the sum as an aggregation function. Note that there is a subtle difference between these two examples. Okay. Here, okay, in this example, because we were applying the aggregate on the purchase amount column, okay. So pandas already knew that the aggregation function should be applied on this column, okay. So here in this dictionary, which is basically add the attribute to the aggregate function, you can just specify the new column names for the aggregated values and the functions that should be used for the aggregation. But here, the case is different. So you don't want to apply the aggregation function on only one column. So you want to apply on two different columns. So that's why you just, when you do group by, you just apply the aggregate on the whole result. And then here, when you just want to give the input to the aggregate function, you should just specify the real, the original column names as the key. And for the value, you just give the aggregation function that you want to use. So there is this probably this subtle difference between these two cases. So this aggregation and using this aggregate method could be a bit confusing, but on the other hand, it's also very useful because you can just do even complicated aggregations by just writing a single line. I hope that it was clear, but if still there is something unclear or anybody has a question, maybe you can ask if you want, or write me in the chat. Yeah, but you will have also the exercises and also the assignments, so you will get used to it. Okay, if there is no questions, I can just move on. Okay, it is also possible to aggregate multiple columns or multiple features instead of just one column. So in the previous examples, we were always aggregating the customer column, okay? But let's say we wanna know the sum of the purchased amounts for each customer in each transaction date. So which means that we want to aggregate two columns. And doing that is just very similar to aggregating one column. So we still do group by, but then here we say that you want to do the group by on two columns, which is customer and transaction date. And we just give these two columns in a form of a list, okay? And again, similarly, we say that, okay, after this aggregation, we wanna just have the values in the purchase amount and the quantity column, and then we wanna just sum, apply the sum function as the aggregating function on these values, okay? Okay, yeah, it should be here. Okay, it's weird that it does not show the. Okay, I forgot that sum. Okay, and if you see the result here, you will see that we have actually two indices in the resulting data frame. So this is kind of what is called a multi-index in pandas. So from previous session that you can see the index of your data frame by just doing that index. If you run it right now, I'm sorry, it doesn't need. See that it's basically well, I should run it on this because the operations are not in place. We will see that it's actually a multi-index, meaning that each index has like two or more values. So, and here it's shown, it is shown as a list of tuples actually. So each tuple is actually a single index of our data frame. So these multi-indices happen when you just aggregate two or more columns at the same time, okay? Okay, this is again the same. There are also some exercises here, and I think the rest I can also, the rest I can also skip because I think it's similar to previous exercises, so I guess you should be able to follow it yourself. Okay, maybe we can do the exercise together, this one. So we wanna get the sum of the purchase amount by customer and transaction date, which is basically similar to here. And we want to count the number of transactions by customer. Okay, so if you wanna just know the sum of the purchase amount by customer and transaction date, we say that because we want to do aggregate on 2 columns, so we should just do again my data. So we do group by, and again we want to do aggregations on 2 columns, so we just give them in a list. So we also want the trans date. Okay, so these are the 2 columns on which you want to do aggregation, and we want the sum of the purchase amount. So for the purchase amount column, we do sum. Okay, and we get the result like this. Again, why you get the result like this is that you only have 1 column in your resulting data frame, although you have like a multi-index here, but you only have 1 column. And whenever this happens, by default, pandas returns an output which has a series type, which is of series type. So that's why you are getting the result like this. Again, here, if I just do reset index, probably I should get a proper data frame, yeah. But note that when I do reset index, I don't have the customer and transaction date as a multi-index anymore, so they are just regular columns, and my index is just these these natural numbers. Okay. Okay, the second exercise, I think it's also very similar to the first one, so I will leave it for you to do it. You should count the number of transactions by customer. So the only difference is that you have to count the transactions. So each transaction is identified by an ID. So you have to basically count these IDs. So I will leave it to you. Okay, and the rest, I think I also leave it for you to follow the rest of the notebook and complete it. Okay, and the last notebook, I think, for the today that I want to review is about merge or join. I mean, these 2 terms may be used interchangeably, actually. So what we mean by merge or join is that there are many cases in which the data that we need to use are basically from different sources. So they are in different data frames. And for example, you want to use 2 features which are not in the same data frame, they are in different data frames. So for using these 2 features or these 2 data sets, you have to first merge them and put them in one data frame and just do your analysis. Okay. And mainly we have basically three types of joins: inner join, outer join, and left and right joins. Well, if I just wanna explain for you the difference between these three types briefly. So inner join basically returns only the samples which are available in both of the data sets. So which are just, shared between both of the data sets. Outer join basically merges two data frame and it just includes all of the values in both of the data frames. So, and if there is a value in one of the data frame, which is not in the other one, you will just get, null values. And left and right joins, are really similar. For example, left join, what left joins gives you is basically when you do a left join, the left data frame in the join, you just keep all of the identifiers or all of the values in the left data frame, and so you just care about the values in the left data frame, which means that if there's a value in the left data frame which is not in the right one, then for the columns from the right data frame, you will just get null values for that sample. Okay. You will get it when we do this exercise. Again, for example, let's say we wanna use the same data frame about the transactions, okay? Okay. But no, we want to also, we have also another data frame, which is about these demographics, and it's essentially some extra information about the customers. So in the first data frame, we had information about the transactions that the customers did. But here we have some sort of, extra information about the customers themselves, like what are their gender, birth date, zip code, etc. Okay. Okay. Let's start with inner join. So the first important thing to know when you want to do a merge is that you want to basically, when you want to merge two data frames, the first thing that you want to know is that on which column you want to merge two data frames. For example, let's say that I want to merge these two data frames so that I have a single data frame that not only contains the transaction data of each customer, but also contains the private data of each customer at the same time as well. So if I want to have such a data frame, I should do a join, okay? But the first question that I have to ask myself is that on which column I have to do the join, which means that is there any identifier in these two data frames, okay, which essentially tell me that these two samples from these two data frames are basically belong to the same customer, okay, in this case, and I have to join the two data frames on these identifier. I mean, in this case, for example, we care about the customers, so we should do the join on customers, which means that, for example, here we have the customer 120621. So when we are joining, we say that we join the two data frames on the customer column, meaning that we take this row. Also here we find the row for which the customer ID is the same, 1206, whatever. And then we join these two rows together, okay? So the first important thing in joining is basically the join key or the merge key. Okay. Okay, so here we want to, as I said, we want to merge these two data frames. The first one is called demographics. The first one is called actually transactions, and the second one is demographics. Okay. Okay, here we just again correct the date time format on the two data frames, transaction date, and we have also the birth date on the other one. And now we want to join. So we say transactions, which is the first data frame, and we do .merge, which is the merging function or the joining function in pandas. And when we do this, the first attribute that we have to specify is basically the right data frame in the join, which is demographics here. The how attribute is basically to specify what type of join you want to do. Here we want to do an inner join, and we want to do it on the customer column. So the join key is customer. Okay, and when we do this, we get the result. So you can see that we have the customer, we have the transaction date and quantity and purchase, etc. But now we have also the personal attributes of each customer, like gender, birth date, and the zip code, etc. Okay. Here we did an inner join, and what happens in an inner join is that if there are some records in the first data frame which are not present in the second one, or vice versa, if there's a customer in the demographics which is not in the transactions, after the inner joins, all of these samples will be lost. Okay. So that's why when you do inner joins, most probably the number of rows in the resulting data set is usually either less or equal than the number of rows in each data set. You can also see it in this example. So for example, in the transactions, we had like, okay, we had 222, so we had almost like this number of rows, which is equal to the result of the join. But if we do the same for the demographics, could be some customers in the demographics data which were not in the transactions, probably. I don't know. Yeah. Well, here, okay, this shouldn't. Yes. So I mean, okay. Well, what happens here is that because demographics only contains the, only contains the unique customers. So so I mean, it only contains the unique customers, whereas in the transactions, you may have like you may have like the same customer identifier repeated in several rows because each customer can have like more than one transaction. Okay. But anyhow, when you do an inner join, you may not get, a data frame which has more number of rows than the the data frames were that you were joining. Okay. Okay, and you can also, okay, so we did inner join in the previous example, but you can also do outer join. And here again, we do the same example, but now on the zone, but now with outer join. So the only thing that we change is the how attribute, and we change it to outer. And by running this, we will see that we get a result, and the number of rows in this result in this data frame is more than the previous one. So there we had like 223,000, but here we have 224,000. And you will see that this we have these rows with null values. And this means that we had some customers in the demographics dataset which were not present in the transaction dataset. And that's why we are getting this not a number values or not a time values in these samples, okay? So by doing author join, we did not lose any data. So we have all of the customers from the demographics and also the transaction dataset. But yeah, because some of the customers were not in transaction dataset, so we get all these null values. Okay, and okay, this is all we have also already covered. It's basically selecting the missing and null values, which you can do with isNull method we just covered last week. And yeah, you can just drop the null values with drop NA. So these are just we have already covered, so I will not go over them. And again, left and right join is also again the same. When you do left join, you use only the keys from the left frame, data frame. And in a right join, you use only the keys from the right data frame. So again, in the same example, if we do a left join, we again get the same number of rows as the transaction data set, okay? Because we only use the keys from that data set, data frame. But if we do a right join, we again get more number of rows because we use the keys, which is here the customer. We use the customer values from the right data set, which is the demographics. And because there were some customers in that data set which were not present in the transactions, so we get all of these null values. So this was it. I mean, this was fairly easy. So that's all that you need to know about joining, I guess. So depending on the application and the problem you are tackling, you may need inner join or left join or right join or author join. But you should always be careful that when you do join, you may lose some of your data points from each of the data sets. So you should always be careful that what are the data points that you are losing and whether you need them or not, or maybe if you wanna, if one of the data sets are really important for you, for example, you don't want to lose any data sample from one of them. Maybe you want to do a left join or right join, or if this is the case for both of them, you want to do an author join. But yeah, this is just like depending on the problem. But on the technical side and the coding side, all you had to know was this. So just using this merge method from pandas. I guess I can stop at the moment. And yeah, if there are no questions, I can just, finish the lab. Okay, well, if you want to ask some questions or you are thinking to ask some, I just have to say 2 more points. So there is this walkthrough tutorial folder, which are basically a set of slides, which are adapted from a class from University of Zurich. So these are also nice slides, and it's about basically pandas operations. So basically what we covered in this lab. So how you can do aggregation, merge, and how you can just do some visualizations with pandas. And we have also this exercises folder. We have just, created 2 small exercises, which is about pandas operations and EDA. So I would recommend you to try to do these exercises at home on your own. And then as you finish them, you can just compare your result with the solutions which is already there. Okay. So that's it from my side. If you have any questions, I'll be happy to answer. Otherwise, we can just finish the session. So is this about the lecture? Because if it is about the lecture, then maybe you should ask Mihalis. So if you mean do you mean the lecture slides? Okay, yeah, maybe better to ask Mihalis. So probably in Slack you can ask him. Yeah. Anything else? Okay, great. So I wish you a happy afternoon, and I will just finish the session right now. Thanks everyone, and we'll see you next week. Bye.